Okay, so now I will be going over question 28. So the first important concept in question 28 is conservation of momentum. Okay, so I've defined momentum before, but basically momentum is mass times velocity. Conservation of momentum is where the mass times velocity initial will equal the final momentum, mass times velocity final. And this will only happen in an isolated system. So that means no external forces can be acting if momentum is conserved. It only happens in an isolated system. So I'll just write the equation for that. So mass 1, velocity 1 initial equals mass 1, velocity 1 final. So as you can see here, it shows conservation of momentum. The next concept I will go over is elastic and inelastic collisions. Okay, so so both of elastic and inelastic collisions both have conservation of momentum. So for both of those, there's conservation of momentum. But for elastic collisions, both momentum is conserved and kinetic energy is conserved. So we can say 1/2 mv squared initial will be equal to 1/2 mv squared final. So in elastic collisions, both kinetic energy and momentum are conserved. And this elastic collisions don't really happen. It's very unlikely for the kinetic energy to be conserved in a collision. Okay, so the next one is inelastic collisions. So in inelastic collisions, momentum is conserved, like I said, but kinetic energy is not conserved. So that's the difference. And in inelastic collisions, there's something called perfectly inelastic collisions. And perfectly inelastic collisions are when the objects stick together and then they go the same velocity final at the end. So the equation for that is m1 v1 initial plus m2 v2 initial is equal to m1 plus m2 and then final velocity. So that's when the objects, they're going and then they stick together and then they go together at a final velocity. Okay, so those are the important concepts. So now I'm going to read question 28. Blocks A, B, and C are aligned along a straight line on a horizontal frictionless surface. The masses of the blocks are m, 2m, and 3m, respectively. Block A is initially moving to the right along with the same line at a speed v, as shown in the figure above. Blocks B and C are initially at rest. Block A collides with and sticks to block B. The two blocks then collide and stick to block C. What is the speed of block C after the collisions? Okay, so first I'm going to draw what's happening here. So I'm going to draw down here. So block A, I'll just say BA is moving at a velocity, and then block B and block C are at rest. So only block A is moving. Okay, so the first thing to look at in this question is it says on a horizontal frictionless surface. So we can assume in this question that it is an isolated system and therefore momentum will be conserved. So that means we can use the m1v, the initial momentum will be equal to the final momentum. The next thing that we can also use in this problem is that it says block A collides with and sticks to block B, and then the two blocks collide with and stick to block C. So that means it will be a perfectly inelastic collision. So we can use this equation up here to solve this question. So I'm going to do it like that. Okay, so ma, mass A, times velocity A plus mb plus velocity B plus mc velocity, oh, I'm sorry, this is times velocity C will equal, like I showed here, ma plus mb plus mc, and then they're sticking together at the end. They're going at a velocity final all together. So MAVA plus MB, BB plus MC BC is equal to that. Okay, so first in the problem, block B and block C are initially at rest. So we can say this is 0 because the velocity is 0. So then we have MB equals MA plus MB plus MC velocity final. And they give us the masses, so we can substitute that in. So we know MA is just going to be M, MB is going to be 2M, and MC is going to be 3M. And they give us that in the problem. Okay, so now remember we're trying to find the velocity final, so we can add these together. So this is 6M times velocity final equals mv, and then what we can do is then we can divide by 6m, and the m's will cancel, so then we get v over 6 is equal to velocity final. So that means that the correct answer to this problem is B. Right here, B, that is the correct answer. So in conclusion, this problem showed important concepts of the conservation of momentum, how it only happens in an isolated system. It also showed important concepts of elastic and inelastic collisions, and we solved it using the equation for perfectly inelastic collisions.